Welcome to today's video. Today, we'll be talking about acids and bases. We'll start by thinking about pH, then examples of acids and bases. We'll also talk about neutralization reactions, titration experiments, and then I'll give you some easy ways to write equations for acid-base reactions. We'll finish today by talking a little bit about strong and weak acids and alkalis. So to begin with, let's look at the pH scale. The pH scale tells you whether something is an acid, a base, or neutral. Just a note at the bottom here, a base and alkali both have a pH greater than 7. A base is a solid, but if it dissolves in water, then it becomes an alkali, so we can think of bases and alkalis as the same thing. Acids have a pH less than 7. Bases/alkalis have a pH greater than 7, and if a substance is neutral, it has a pH of 7. Let's look at some examples of acids. First one, hydrochloric acid. Hydrochloric acid has the symbol HCl. Sulfuric acid has sulfur in it. The equation is H2SO4. Nitric acid has nitrogen in it, HNO3. You'll notice that all of these have hydrogen and do not contain any metals. That's really important. And in an acid, the hydrogen in the written chemical equation always comes first. For example, HCl. All acids form H+ ions when added to water. That means that when you dissolve the acid in water, it forms H+. Note that all acidic solutions are aqueous. HCl gas plus H2O. HCl dissolves in water to form H+ and Cl-. HCl in its pure form is a gas. It is still an acidic gas. But when we dissolve it in water and it's aqueous, then it becomes an aqueous acidic solution. Let's have a think about alkalis and bases. Remember, an alkaline and base are both the same thing, just that a base is a solid and an alkali is aqueous. First one, sodium hydroxide, and AOH. Hydroxides are alkalis. They dissolve in water. The next type of substance is called a carbonate, and in this example we have potassium carbonate. Carbonates are bases. They are generally insoluble. Oxides. Calcium oxide is another example of a base. Although some oxides are soluble, but they would all be considered to have a pH greater than 7. So they fall into the same category. There are alkalis and bases. The fourth one here is ammonia. The formula is NH3. Ammonia is a weak alkali. The reason it's different is because it does not contain a metal. But remember what we said about acids. Acids have the H in the formula first. This does not. This is just NH3. It doesn't contain a metal, but it's still a base. All alkalis form OH- ions when added to water. As an example here, we have NaOH forming Na+ and O- when dissolved in water. Neutralization reactions. Again, we have our pH scale. When an acid reacts with a base or an alkali, they neutralize one another. This means that they come together to form products which have a pH of 7. So if an acid has a pH of 1 and it reacts with an alkali that has a pH of 14, they will come together to form a substance that has a pH of 7. That means they have neutralized one another. 7 is neutral. Let's look at some of these reactions. Acid plus base makes salt plus water. This means that H+ from the acid reacts with OH- from the base to form H2O. Water always forms as a product with salt. The formula of the salt comes from the combination of the acid and the alkali or base. So for example, HCl+ and AOH. When you are figuring out the formula of the salt, it's always the metal from the alkali and the nonmetal part of the acid when you remove hydrogen. So if you remove hydrogen from HCl, you get Cl. Formula of the salt is therefore NaCl. The hydrogen from the acid and the OH from the alkali combine to make water. Let's look at a titration experiment. This is an experiment that would be used to add an acid to an alkali in a neutralization reaction. We'll study this more in our lesson about making salts. Because both substances are aqueous, you can put the acid in the burette and the alkali in the conical flask. You also have to add an indicator. We'll look at these in a second. But indicators are one color in an acid and another color in an alkali. As you add the acid to the alkali, when neutralization occurs, the indicator will change color. And when it changes color, you stop adding the acid. You know at this point that you have made your salt plus water because as the indicator in the flask changes color, that means neutralization has occurred. Indicators, as I mentioned, are substances that change color when a solution is more acidic or more alkali. As you add an acid to an alkali, once it becomes acidic, the indicator will change color. Common indicators you need to know about are methyl orange, which is red in an acid, and yellow in an alkali. Phenolphthalein, which is colorless when it's in an acidic solution, and pink when it's in an alkali solution. You also have litmus paper. Litmus blue paper is used to test for acids. If you dip the piece of paper into an acid, it will turn red. Litmus red paper is used to test for alkalis. When you dip it into the alkali, it will turn blue. Let's look at some easy ways to remember these reactions. The first one is BAWS, BAWS. That stands for base plus acid makes water plus salt. This is very useful because you can remember that your products are water and salt, and all you need to do is figure out the formula of the salt if asked to write an equation. As an example, we've got nitric acid plus magnesium oxide making magnesium nitrate plus water. When writing the formula of the salt, you take the metal from the base, then you add the part of the acid minus the hydrogen. So for example, if we remove hydrogen from HNO3, we have only NO3 remaining. The charge on NO3, which is a nitrate ion, is -1. When Mg2 plus and NO3 1- join together, we get MgNO3 We need two nitrates to cancel the charge of the 2 plus on the magnesium. Or if we put the nitrate in brackets, we can use the swap and drop method that we learned in an earlier unit. Move the 2 from the magnesium 2 plus down and cross over, and we get NO3 Move the 1 from the nitrate down, and we get 1 Mg. And remember, plus water. It's a neutralization reaction, always plus water. The next acronym is ACCOWS, AC cows. Students of mine in the past have remembered this as air-conditioned cows. Acid plus carbonate makes carbon dioxide plus water plus salt. Carbonate is a metal carbonate. As we discussed, this is a type of base. As an example, sulfuric acid plus calcium carbonate makes calcium sulfate, that is our salt, plus water, plus carbon dioxide. The point of this is to remember that when you have a carbonate, you always form carbon dioxide as a product in the reaction. So if AC cows helps you to remember that the products you make are CO, carbon dioxide, W, water, and S, salt. Fantastic. Now let's talk just a tiny bit about acid strength to finish. Earlier, we said that we have strong and weak acids. This is a strong acid. You can see it dissociates 100% into H+ and Cl-. That means that every single molecule of HCl will break apart when it is added to water, when it is aqueous. Remember, pH is a measure of hydrogen. H in pH means hydrogen. So the more hydrogen, the stronger the acid. Weak acids. Weak acids only dissociate by around 1%. Dissociate here is an important keyword. That means that only 1% of these ethanoic acid molecules will lose their hydrogen ion to form the ethanoate ion with a minus charge and H+. That means that there's less hydrogen ions in the solution, and therefore, the acid strength is lower. The pH will be higher. The pH of a weak acid would be around 3 or 4. The pH of a strong acid would be around 1 or 2. You can see I've drawn the displayed formula here as we talked about in our organic chemistry unit. This shows the ethanoic acid breaking apart to form the ethanoate ion and the H+ as separate. This would be more of a reversible reaction. Most of the molecules will remain as ethanoic acid with the hydrogen attached. As a side note, weak acids can still be neutralized completely by alkalis or bases. The only difference is that the reaction will be slower than it would be with a strong acid. Thank you very much for joining me today in this lesson about acids and alkalis. Please go ahead now and work through some practice questions.